Let's now go through this problem here. It says the city of Robbville contains 8 landmarks denoted as vertices N to U on the network diagram below. The edges of this network represent the roads that link the 8 landmarks. So the edges represent the roads, and we're also told that the vertices on the network represent the 8 landmarks. So vertices represent landmarks, edges represent roads. Okay, it says write down the degree of vertex U. So let's look at vertex U here. And as you can see, we have 1, 2, 3, 4 edges meeting that vertex. So that means it's 4. So we put a 4 there. We then continue down and we read part B, which says, James wants to check the surface of each of the roads, but does not want to repeat any roads. He will begin his journey at landmark N. At which landmark must he finish his journey? All right, so this is getting us to think for a moment about, what exactly are we after? So the fact that he wants to check the surface of the roads, but he doesn't want to repeat any of the roads, well, we know that the roads are our edges. So if we're concerned about edges, we know that Euler is concerned about edges. So all of this talk about roads and not wanting to repeat roads is our clue that we're concerned about edges. And we want to go through every edge only once. So immediately we're thinking, all right, edges means we're dealing with Euler. And if we want to repeat all the roads only once, and we want to end at, at which landmark must he finish his journey at? Well, is he going to have to finish his journey back where he started? Or perhaps will he finish his journey somewhere else? Well, how can we figure out whether or not we're dealing with an Euler trail or an Euler circuit? Well, what we can do is we can list the degree of each vertex here. So let's do that. This is going to be 4. This is going to be 2, this is going to be 4, this is going to be 2, this is going to be 3, this is going to be 2, this is going to be 3. So immediately, the fact that we've got a degree of 3 here and a degree of 3 there, and then the rest are even, that's our immediate clue that what we're dealing with here is an Euler trail. Because remember, by definition, if we have 2 odd and the rest are even, that means that a trail is what we're after, an Euler trail. Now, we're told that we're beginning our journey at landmark N. So we're beginning here. Where are we going to have to end? Well, we know that we're going to have to end at our other odd number because we start and end at odd numbers for Euler trails. So that means we're going to end at P. So we can come here and we can say we're going to end at P. Perfect. What is the mathematical name for the type of journey James wants to make? This is called an Euler trail. Euler trail. Perfect. All right, let's keep on going. It then says, regardless of which route James decides to make, how many of the landmarks, including those at the start and finish, will he see on exactly 2 occasions? All right, so to figure this out, we're going to have to kind of picture this trail that he's going to take. So we're starting at N, and what we need to do is get to the end here. And remember, we can only go through each edge only once. We can hit a vertex more than once, but each edge only once. All right, let's see how we go here. And hopefully we have some success. Okay, we're going to go there, then there, then there, then let's go there, then we'll go here, then we'll go there, we'll go there, we'll go here, we'll go there, we'll hit there, and then we can go back. I only hit every edge only once, and that's it. Now, how many landmarks am I going to see more than once? Well, hopefully you can see that. Do you see how I hit N twice? I hit T twice, I hit P twice, I hit R twice, I hit U twice. As you can see, I only hit O once, I hit Q once, I hit S once. Now, you could have drawn that in different ways, but you're always going to end up hitting certain landmarks 2 times. It's always going to end up happening. So that means 1, 2, 3, 4, 5. There's going to be 5 places where I'm going to see the landmark twice. So we can come here and we can put a 5 there. Perfect. Hopefully that made sense. We'll now go through part C.